Bayene. In this short video, I'm going to show the shortest and the easiest steps of slope analysis. The required data for this analysis digital elevation model. For this analysis, I'm going to use demi catchment or watershed digital elevation model or raster data, which is the middle part of Omo River Basin in Ethiopia. Here are the steps. Follow. Open the arc map. Yes, this is the arc map. My arc map is the version of 10 point. I'm sorry, 10.8. This is a display of arc map 10.8. Just looks like the other arc map display looks like this one. Then by using a data button, add digital elevation model. First I fixed the digital elevation model, the demi 30 meter by 30 meter digital elevation model. How I know the resolution of the raster data is 30 by 30? Let us click here and again properties. We can get simply the elevation of the digital meter. Here's the general. In the general, its name is here. Again, source it says column is row. Again, number of bands 1. Cell sizes, which tells us about the resolution of the digital elevation model. What way I'm going to analyze this. Here is 30.81 by 30.81, which is x is 30.8 and y is 30.8. Similar resolution is provided for the digital elevation models. It's generally to see about the resolution of the digital elevation model. For this reason, what the digital elevation model for this data is 30 by 30 meter. 30 by 30 meter. Another way we can see the digital elevation model is 30 by 30 or not. You can see here. I'm sorry. For example, we can measure its distance. We can measure this one. This is in measure by what? Distance in meter. Yes, it's meter. Again, we can measure this one, like here. Again, length is meter. Not this one. I'm sorry, this one. Let me click here. Yes, it's around 30 by 30. 28 or 30. This is 30 by 30. It shows 30 by 30. Again, you can measure from here to here. Again, look this one is 30 by 30. Yes, this is showed. This digital elevation model is 30 by 30 meter. To normal extent, here's digital elevation model. To analyze the slope, first, what does it mean a slope is? What does it mean a slope is? A slope is a gradient. A gradient, which is the steepest part of the digital elevation model. Here's its definition is found here. Identify the slope or gradient or steepness from each cell of the raster. Here is also another description of the slope. Here is another description of the slopes, which is only found in 10.8 or the latest version of ArcMap. How ArcGIS compute or work slope or how slopes work. The tool or ArcMap identifies the steepness at each cell of raster surface. The lower the slope value indicates, the flatter the terrain or the surface. The higher value of the slope indicates the steeper or the steepest of the terrain. We understood? For example, the lower value of this slope of the raster data. The lower value of the slope indicates the flatter surface, and the higher value of the slope indicates the steepest surface of the catchment. In these three triangles, this is angle theta. A slope, by the way, computed by two unit systems. For example, one is in degree, or the next one is percent or percent rise. In degree, it's directly calculated as rise per run equals tan theta, which is this triangle degree is 30 by 30 degree. This triangle is 45 degree. This triangle is 76 degree. Again, the percent of the slope is 58 for this triangle A. The slope percent of the slope for B is 100. The percent of the slope of C is 373, which is presented as example. Don't complicate it. Then again, a slope, the calculation methods, and the edge effect, which is two types of calculation methods are provided in ArcMap 10.8, which is planar or geodesic calculation is the methods parameters. Here the planar methods calculation is all methods are described here. The calculations are described here in your time, or in if you want to read further, you can get full information about the calculation. Again, this method is found here. I'm going to the computation parts of the slope analysis. Here is the input data from my digital elevation model of the measurements. The output place of my raster or slope is slope 30. A slope 30 by 30. Or I mean that degree is up to you. Then it's also by degree. It is an option degree in percent rise. The planar or geodesic. I'm going to use the planar. The other as default as it is. Let's click on OK. Just OK. Yes, it automatically gives the slope of. Here is the reddest one is the steepest part of the catchment, and the green one is the flattest part of the catchment. Is the lower value indicates the flattest. The higher values, higher. This is by the way in degree. The higher value indicates it is the steepest part of the catchment. Then this writing system is not good to see. We can adjust it by setting here is symbology part. You can use symbology right here in right click here. Then formal levels here is 10. I'm going to use let me deduct which is number of decimal places I can use here. If I say but the problem, no problem, I can use it. Yeah, look, it's cute. Apply OK without changing the color. I can use yes. If it is not good, you can use again two forms. Again here symbology is I said formal level is here is if I2 is deducts one value from the portion, or otherwise you can say it's apply OK. Yes, to see it's nice to say. Otherwise it's if you want to in one decimal place, you can here right click on here formal level 1. It's nice to see the degree of the catchment. Yeah, that's why. If you want to change the color, here you can change the color. Click on here. For example, I click here change. I'm going to change the color black. Look, this one. This black again. You can change the color here. This one is this color. You can change it. Make it again. You can change the color. You can make this one color. Look, also you can change this color. Red one is going to be another color. This one if you want, you can change this one. This color, right? Look, this color one. Again, the next option is a slope by percent rise. Then double click on the slope. Again, input data is digital elevation model. Output is the slope in percent. This one is percent. Okay. Yeah, here's another name is provided there. Slope in percent. Automatically it can accept it. Yeah, here it changed percent riser. Yes, statistics. This you can take it as a planner. Again, you can click on automatically it is calculate the percent. As similar, you can adjust it is format level. Is format level. Then in percent format level is what? 1. For example, look how looks it 70 to 100%. Yeah, or sometimes this is without decimal level. It's gives complications. Say, let me gives 2. Let me see it. What is again need this extra format level 3. Yeah, what is going to look like? Yeah, now it's good. It's good. You can see it. This the similar explanation as previous. For example, the flattest surface is 0 up to 10. Here is 0 up to 4.5. The steepest part is 107 up to 206. This is the steepness of the slope. Steepness of slope. You can see this one. This is slope. Again, we can again calculate or compute the slope by geodesic. Slope degree geodesic. It is same. Here is planar, is not degree. This degree is geodesic. And what the difference is it? It's meter. Yeah, it's meter. Then is it calculating, executing the slope of geodesic. Yeah, it's complete. What's the difference of geodesic and what is that's of planar? Planar is the deepest is 65. Geodesic is the deepest one is 63. Let us see here. Again, level portion for model level. Yeah, 1 before 2. Let us see how it looks like. Yeah, have you seen 63 difference? Their difference. Slope in degree. Here is I can bring here. You can see the difference. It's the value difference. The computation, the planar and the geodesic is different from that slope analysis of planar. Again, degree by the same data I'm going to use. Here is a slope in percent and geodesic. Let us see. Here is planar, not planar. In percent, here is percent. I'm going to change. Is a planar in geodesic. Is meter. It's meter or what? You can leave this meter what in your option. Look, here difference. Look this one. Again, adjust the level. Again, adjust the level. Formal level. It is 2 or 3. Let me see. 3. Yeah. Apply. Yeah, it is much more. Again, 2 or 1. What's the problem if I make it 1? Yes. Nice. Look, difference is about this, which is in degree, percent, and let me nearby near. We can see the difference of the slope in percent in planar and the slope in geodesic, which is in the planar 216 and the geodesic 201, the deepest portion. The other is almost similar. The value difference is this is all about the slope analysis. Thank you for attending.